Okay, welcome back. Continuing with our symmetry examples, we'll look at inverse sine value of negative 0.5, inverse cosine value of negative 0.5, and inverse tangent value of negative 1. And I'll identify the inverse sine value as 210 degrees. And for the inverse cosine value, that angle in sine is for the inverse sine value of negative 0.5. For cosine, the inverse cosine value of negative 0.5, angle of 120 degrees. And for an inverse tangent value of negative 1, angle of 135 degrees. Now in all cases, as we saw in the previous examples, I have more than one angle with these inverse trig values in the circle. So the way I identify my second angle with an inverse sine value of negative 0.5 is I identify that the sine value is based on the y-coordinate. So looking at the value of negative 0.5 on the y-coordinate and crossing at that point on the y-axis, I'll hit another point on the circle, and that angle is 330 degrees. In the case of cosine, the negative 0.5 relates to the x-axis, so at negative 0.5 on the x-axis, I can go down to another point on the circle, and this is going to be an angle of 240 degrees. And then for tangent, I cross the circle to get to the point 180 degrees from 135, which will be 315 degrees. This again is the concept of symmetry. So let's look at the identities that we were evaluating in the previous example. For sine, sine of 180 degrees minus the angle equals sine of the angle. For cosine, cosine of 360 degrees minus the angle is cosine of angle. And for tangent, tangent of 180 degrees plus the angle is tangent of angle. So now let's actually work through these calculations and see what the results are. Sine of 180 degrees minus 210 degrees equals sine of negative 30 degrees. Note that negative in front of the angle means I go clockwise, and moving negative 30 degrees gets me to the same position as positive 330 degrees. So to say that I'm looking at sine of negative 30 degrees is the same as sine of 330 degrees. Those are the same position on the circle. Now what if I use the other angle, 330 degrees? Sine of 180 degrees minus 330 degrees equals the sine of negative 150 degrees. And I don't see that on the circle, but again, the negative means I go clockwise, and if I go clockwise, negative 150 degrees is the same position as positive 210 degrees. In the case of cosine, whether I input 240 degrees or 120 degrees, I'll get the other angle as the result, so no surprises in those calculations. In the case of tangent, if I put in 135 degrees, I get 315 degrees. But what if I put in 315 degrees? The tangent of 180 degrees plus 315 degrees equals tangent of 495 degrees. Starting from 0, working my way around the circle 360 degrees and continuing another 135 degrees, I have the angle of 495 degrees in the same position as 135 degrees. Now let's see what our calculator outputs are for these inverse tangent function values. When I calculate inverse sine for negative 0.5, I have negative 30 degrees, which is the same as positive 330 degrees, and that's one of the angles on my circle. I know that the calculator is only going to give me one. The way I find the other is I use my symmetry formula. For inverse cosine of negative 0.5, I have an output value of 120 degrees, and again, knowing there's a second angle associated with that inverse cosine value, I can use my symmetry formula to find the second angle of 240 degrees. And in the case of tangent, an inverse tangent value of negative 1 gives me an output of negative 45 degrees, which is the same as 315 degrees. One of the angles I've identified, and the other I can find again using my symmetry formula. So let's summarize with a comparison between trig functions and inverse trig functions. When I'm dealing with the trig function, I have an angle, and I'm asked to find a trig value associated with that angle. And in solving these problems, I have one solution. So if I want to find the tangent of 60 degrees or the cosine of 110 degrees, there's only one solution. In contrast, when I'm dealing with an inverse trig function, here I have the trig value, and I want to identify the angle associated with that value. And there will be more than one solution. And I use my given interval to evaluate possible solutions. This ends the trigonometry lesson on periodicity and symmetry. It takes some time to develop an understanding of trigonometry. With practice, working through trig function problems and inverse trig function problems, you'll develop your understanding of these concepts. There's more to come. I look forward to seeing you in the next lesson.